Sorry, guys. Unfortunately, I pressed the wrong button and it stopped recording. So this lesson's in two parts. So as I was saying before, greatest common factor could be variables too, right? So first thing I look at is this. I look at 9, 6, and 1. Do they have something in common? Well, 1, but we're not going to factor out a 1. So let's look at the variable. They all have x's. So we know we're going to take out an x. Now, I said earlier, remember, it's the smallest exponent. So 4, 3, 2. So I'm going to take out an x squared. Now, when I factor out an x squared, I'm left with, again, remember, I'm going to go quickly. So 9x squared plus 6x plus, now be careful, a lot of people forget this. X squared divided by x squared is 1. What I want you to remember is when you factor something out, the terms don't go away. If I have 3 terms and I factor something out, I still have 3 terms. Okay? Now, we're going to ignore this, but we know it's still there, right? So A times C. Then we're going to ask ourselves, what two numbers multiply to give us 9, but add to give us 6? Hopefully you're thinking 3 and 3. And I don't have to worry about my negatives. So let's make our box. Okay, that first term right there, 9x squared, constant, that's 1, and then our 2 other terms. All right, let's see. On the left, what's in common? 3x. On the right, what's in common? Well, there's really nothing in common is what would pop in your head. But again, what did I say? Never put nothing down. In this case, we got to put 1 down. Okay, at the top, what's in common? 3x. Okay, what's in common on the bottom? Nothing. 1. So 3x plus 1 times 3x plus 1, but we're not done yet because, hey, we got to remember our greatest common factor, which was x squared. And now we are done. I do want to show you that this can be written out differently. Because these two are the same, we can actually rewrite this, and either way is fine. So if you do not want to write this way, you don't have to. We could say x squared, of course, that's not going anywhere. 3x plus 1, but because it's multiplied by itself, remember that means squared. So we can do that both ways. Okay, here we did a coefficient. This one we did a variable. Let's see if we can do both. What's common between 3, 6, and 45? Well, hopefully you said 3. Then they all have x's. Use the smallest exponent, which is 3. Okay, let's see what's left over. So we get x squared minus 2x minus, let's see, that would be 115. Okay. Remember, ignore this for now, but it doesn't go away. So here we have 1 is our A times negative 15 is our C. So we get negative 15. Then we say what two numbers multiply to give us negative 15, but add to give us that B value, which is negative 2. So how can we make 15? 1 and 15, 3 and 5. 3 and 5 make 2, right? 3 and 5. And the reason why I said make 2 is because I'm thinking subtraction. So, which is good because we know one's positive and one's negative since this is negative 15. But we want a negative 2. So which one of these is negative? The 5. Make our box. Okay. We have x squared here, negative 15 here. We have a 3x, negative 5x. Okay, let's see what's in common. On the left, only thing in common is x. On the right, what's in common? 3. It's a positive 3 since this top one's positive. On the top, what's in common? X. On the bottom, what's in common? Well, 5, but it's negative because that one's negative. So x plus 3 times x minus 5. And let's not forget our greatest common factor, which is 3x cubed. All right. Now, what's going to happen in it, as you can see, I say 3 and 4. I want you to do number 3 and 4 on your 4-question worksheet. You're going to make sure you check that off with me. But once you check it off, make sure you come back to your notes and practice this a little bit, okay? All right, so hopefully you got everything checked off. This is a special pattern that I want to show you some tricks with, because if you get a difference of squares, there's actually such this easy way to do it. Okay, so I'm going to show you the trick. Now, difference of squares. What does difference mean? Difference is subtraction. So it must be subtraction. Now, squares. Squares meaning perfect squares. What are your perfect squares? Well, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So on and so on. So your perfect squares are 1, 4, 9, 16, 25, 36, so on and so on and so on. Okay. Now, the reason why, if you can recognize that subtraction and that difference in the perfect squares, it's an easy peasy way to do it. So the idea is, if you know they're perfect squares and it's subtraction there, the difference of squares, all you have to do is take the square root of each number, and then you have one binomial with an addition and one binomial with a subtraction. So watch. So don't forget, this is 1. First, I check for subtraction. Good. Next, greatest common factor. There are none. 1 and 25. Are those perfect squares? Yes, they are. So I'm going to take the square root, take the square root. Okay, what's the square root of 1x? X. Right? So x there and x. What's the square root of 25? 5. And then guess what? One's addition, one's subtraction. Ta-da! We are done. I love this. It's so great when you recognize difference of squares. Okay, next one. First subtraction. Yes, done. Okay, greatest common factor. Anything common between 4 and 81? No. So now we're going to take the square root, because 4 and 81 are perfect squares. What's the square root of 4x squared? Well, the square root of 4 is 2. So we have 2x, 2x. What's the square root of 81? 9. One's addition, one subtraction. Yay! Okay. Now, by the way, if you get to a number that is not a perfect square, then just leave it as is. We don't want decimals here. So if you're using your calculator to do your square roots and you come out with a decimal, just means we can't do it, okay? So number C, I like it. It's subtraction. Do we have a greatest common factor? No, we don't. There's nothing common between 9 and 49. Is 9 a perfect square? Yes, it is. Is 49 a perfect square? Yes, it is. And as you can see, x squared, y squared are the same. They're perfect squares. So how do you get 9x squared? Well, that's 3x. How do you get 49y squared? Well, that's 7y. And knowing this, one's addition, one's subtraction, done. Okay, this is a big hint right here. What's wrong with this right here? Not subtraction, which means we can't do difference of squares. But if you look at this, we could still factor something out. They have something in common. There is a greatest common factor. What is common between 12 and 27? Hopefully you can say 3. So 3 times, and it's leaving us with 4x squared plus 27 divided by 3 is 9. Now again, very tempting, right? Because 4 is a perfect square and 9 is a perfect square, right? 2 and 3. But it is not subtraction, so we cannot do our trick. Actually, right there, that is factored and we are done. Okay, please start your work to see how you can do all by yourself.